Hello everyone, you're welcome to class. So for this class, I'll be taking us through a brief intro on reservoir engineering. Um, so as a reservoir engineer, the precise knowledge of the behavior of your crude oil, your natural gas, and water, whether as singly or in combination under static condition or in motion in the reservoir rock and in pipes and under changing temperature and pressure is the main concern of every petroleum engineer. So what this is trying to say is that as a reservoir engineer, or so to speak as a petroleum engineer, you have to understand the behavior of your crude oil and your natural gas and your water, either as individual uh, reservoir fluids or in combination. So you can have combination of your natural gas and your oil, or the combination of your natural gas and water, your crude oil and water, or you have the three all together. But in all cases, most of the time, you have presence of water as well in your reservoir, because water is one of the constant fluids that we have in the subsurface all over the earth. So you also have to understand the changing temperature and pressure which occurs as you produce these fluids from your reservoir. So these are the main concerns of the reservoir engineer. You have to understand the changing temperature and pressure and all other reservoir conditions that are prevalent during your production, and also the flow of your fluids in the reservoir rock. We have fluid flow in porous media, and as well the flow of fluids in pipes as you produce to the surface. So quickly, let's look at what a petroleum system is. A petroleum system is a dynamic hydrocarbon system that functions in a restricted geologic space and time scale. So for a petroleum system to have existed, there must have been a lot of geologic occurrences or events that has occurred within a particular time, which has led to the formation of reservoir fluids at a point in time. And then we have geologic events which had occurred in such a time scale whereby you have the accumulation of such fluids, and then the uh, event of a reservoir, whether a gas reservoir or an oil reservoir. So there is a timely convergence of such geologic events essential for the formation of petroleum deposits. Okay, so we have here, I'm trying to show us here some geologic time scale. You can try to zoom this, so that you can see some of the geologic time scale that exists before now. Uh, Here is showing also the geologic time scale. You have the eon, the era, and the period. The EON, is the largest geologic time scale, which is measured in immeasurable number of years, actually, very long time. The era is characterized by geologic events which had occurred within maybe hundred or millions of years. And the era is followed by a period. A period is characterized by tens of millions of years. Okay, so it's the least geologic time scale that is used in characterizing an event. This is followed by an era, and the largest is eon. So here you see the Paleozoic eon. Under it, you have the Cenozoic, Mesozoic, Paleozoic, whether late or early, and under each era you have periods. Okay, you have the Paleocene, um, Cretaceous period under Mesozoic. You have the Jurassic period under Mesozoic, and then you have Under the Paleozoic, you have the Permian, you have the Carboniferous, you have the Variant. So if you look at all these timing under this time scale, all of them are characterized by events which actually occurred at a certain point in time. So here you can see the figure to your right. For example, you as a reservoir engineer, you want to drill for oil. You must be able to tell in which region you're actually drilling. Are you drilling in the Cenozoic, producing from the Cenozoic or Mesozoic or the Paleozoic um, Paleozoic era? So these are characterized by, you can see the millions of years, 1.8, 5.3, 23 million years, 33.9, 55.8, 65.5 million years, and then increases downwards. So depending on how far you go into the subsurface, your reservoir is characterized by um, a geologic event. You have the geologic space and then the time scale. Okay, so this is quite interesting, and I'm sure you will also come across it in your petroleum, more in your petroleum geology. So what are the geologic events that we as reservoir engineers or petroleum engineers are concerned about? We have the maturation of the source rock. um, you must have been taught what are source rocks, examples of source rocks. We have the maturation of the source rocks, which are fine-grained sediment with sufficient amount of organic matter. They generate and release enough hydrocarbons to form commercial accumulation of oil or gas. So after the maturation of the source rock and the generation or release of such hydrocarbons, we have the expulsion, like the release of such hydrocarbons from the source rock. So after the release, there is a release uh, of the reservoir fluids. From there, we have migration. So there is expulsion from the source rock, and then as it is expelled, then we have migration of such fluids. After migration, this occurs also over a geologic time frame. So it's not something that happened over a short period of time. It happened over a lengthy period of time. Okay, so you have the expulsion, then you have the migration that occurs over also over a time scale. And then after the migration, you got to a point in the in time whereby the reservoir, the fluids accumulate, and then you have the accumulation, you have the occurrence of traps. I'm sure you have done a little on traps, your structural traps, stratigraphic traps, different types of traps that you have. So you have the trapping system, which holds the fluids, and then that becomes the reservoir system. And then you can also have the extension of such reservoir system as time within the geologic, okay, time. Okay, so here we see the cap rock. Okay, let me start from here. We see the source rock. Here, there occurs the maturation. There being accumulation of organic matter here, accumulation of organic matter here, and then they're buried for millions of years. And then you have we have such organic matter buried for millions of years under extreme temperatures and pressures. Okay, and also other um, you have it buried under extreme temperatures and pressures. So you have this your source rock. From your source rock, you have the maturation occur, and then the expulsion occurs, and then you have it traveling down, and then you have it here. You have the accumulation occurring here. This is the seal. There's a trapping system, a trap system. Okay, and then you have the seal, you have trap system. These are the seals. Okay, the seals, you have your reservoir rock in here, which holds the reservoir reservoir fluid that travels down, okay, within the system. So here you can see the system. You have the cap rock, you have your gas, you have your oil, you have your source rock from which you have the expulsion of the reservoir fluids, okay, and then you have your reservoir rock within here, and then you have your cap rock uh, and the trapping system which holds the reservoir fluids and prevent the reservoir fluids from further flowing. Okay, so accumulation, the generation occurs in the source rock, the traveling, that's the migration, and then you have the accumulation, and then you have the trapping system. So you have to understand all this as geologists, and a bit of what the geologists know. You have to know it as a reservoir engineer. Okay, so you have to understand it because this was make you a total reservoir engineer. Okay, so what is reservoir engineer itself? Is the application of basic scientific intelligence to the optimal recovery of oil and gas from subsurface reservoir. So we have seen a reservoir occurring here after millions of years that a lot of geologic events has occurred. You have the fluid here. So as a reservoir engineer, you are more interested in this zone. You want to produce your oil. If you're interested in your oil and it's a gas reservoir, you want to produce your gas. Okay. And uh, your oil and your gas is your basic interest, especially as a reservoir engineer. So it has application of scientific intelligence, application of science, so to speak. Okay, the application of science, the knowledge of science, okay, to the optimal recovery of oil and gas from subsurface reservoirs. And then as reservoir engineer, you have three basic three fundamental rules. Number one is to estimate the hydrocarbon resource volume in place. So you want to know the resource volume in place as your reserve. You want to understand what is the resource volume, either your oil or your gas. You want to know how much of it is in place in your reservoir. So you have four basic major resource volume. For some texts, you may find more uh, depending on the grouping, depending on the author. Okay, so there are four basic resource volumes. You have the stock tank oil initially in place. That's the total amount of oil that you have um, in your reservoir. Then the free gas initially in place, the solution gas, we said, I believe we discussed some few things about solution gas, your RS, the solution gas initially in place, and the condensate initially in place. So you are interested in this as a reservoir engineer. And then the second fundamental role of a reservoir engineer to determine the recovery factor. To determine the recovery factor, your recovery factor is your ultimate recovery um, fully divided by your hydrocarbon initially in place. So your ultimate recovery is how much you can actually bring out from your reservoir, how much you can produce from your reservoir. Because your reservoir is at great depth in the subsurface, you cannot produce everything. It is quite impossible for you to produce everything from your reservoir. So the amount you can bring out from the subsurface, okay, over time as you produce is your ultimate recovery. And then the total hydrocarbon present in that reservoir is your hydrocarbon initially in place. So you have to be able to estimate the recovery factor based on the hydrocarbon initially in place and then your ultimate recovery, and that gives your recovery factor which exists between 1 and 10. Okay, so your recovery factor can never be 100%. That means it can never be 10. It will occur between 1 and 10. It can never be 100% because of the physics of the reservoir system, such as the forces which occurs within your reservoir system, your wettability, your permeability, So the physics of the reservoir system makes it impossible for you to have a recovery factor which is 100%. Okay, you can have 80, depending on the drive of the system. We have said some few things about drives, reservoir drives. Depending on the drive of the system, can have 80, as high as 80 or 80 plus, but it can never be 100%. And then you have two major recovery factors. You have the economic recovery factor, which is governed by the current economic circumstance, and ever increasingly by environmental and ecological considerations. One of the time by which this affected the whole world was during the COVID. That's a very good example for you to understand what economic recovery factor is. As at that time, the oil price went down. It was quite low, and then it was not economical for because of effect of COVID. It was not economical for most oil companies to produce, so most wells were shutting at that period. Oil production dropped, it dipped, so it was not economical for oil companies to produce during the COVID season, and even post-COVID. Okay, it took some time before the oil IOCs, the oil companies begin to pick up um, the production of oil. Okay, and then as oil prices likewise improve, so it must economical, okay, for you to recover oil or to produce your reservoir fluid. It must be governed by the current economic circumstance. You don't want your company you're working for to go bankrupt. You want them to make profits. For every company, profit is a major issue. Okay, profit is the focus, to make profit. So you must consider uh, the international oil price in the oil market, and your company at that time. So generally, the economic recovery factor is very important. It's very important. Okay. Um, and then secondly, the technical recovery factor governed by the physics of the reservoir system, reservoir fluid system. So you have to have a full understanding of your reservoir system. We talk about the waterability, the forces, the pendular forces, the permeabilities, fluid flow through your porous media. You have to understand the technical, the physics of your reservoir system. The forces that govern your reservoir system, your drives, what are the drives that are available, what are the combination drives that you can leverage on to fully produce your reservoir. Okay, and then are you producing onshore or offshore? What are the equipment that need to be deployed? Okay, so all these things under your technical recovery factor, very important. And then you don't want to deploy um, equipment, to deploy staff to the field, and then you don't have a good understanding of the forces that are operating within your reservoir system. So the technical understanding of the physics of your reservoir system is quite important and needs to be well understood. Okay, so for instance, we have here, I believe from the previous videos, you have a basic understanding of what this is about. You have the volume of your oil here, the volume of your gas, volume of your water. You have your aquifer. We said a few things about your aquifer, and then you have your gas cap, So all these are drives that contribute, okay, to the production of oil from your reservoir. Okay, so here, your aquifer backs up the reservoir, provides energy. Then you have a change in volume of water, change in volume of oil, the change in volume of gas, as a result of this gas cap expansion, as a result of aquifer expansion as well. You have a change in volume of water. So your total production is the change in volume of oil plus change in volume of water plus change in volume of gas. Okay, so primary recovery, oil recovery resulting from oil, water, and gas expansion. So this is also part of the physics of the system, which you have to fully understand before you can determine your technical recovery factor. Very important. So the diagram which I just showed us, illustrate two major facts. And the first is that to produce an oil reservoir, well should be drilled into the oil zone. You don't want to produce oil from your reservoir and then drill into the gas zone. You want to drill into the oil zone. Okay. And then secondly, if the reservoir is in contact with a gas cap and aquifer, the oil production due to a uniform pressure drop, that's the DP, in the entire system, we have components due to separate expansion of oil, gas, and water. So what that means is that if there is a presence of gas cap, there is a presence of an aquifer, and the oil system itself, they all contribute a form they help contribute the energy to the drive of the reservoir system. So there's an energy contributed by the gas cap, there's an energy contributed by the aquifer, and there's an energy contributed by the expansion of oil within the system itself. So the total oil production is as a result of the expansion of oil, expansion of water, and the expansion of gas. Expansion of gas. Okay, so just a minute. So when you bring your compressibility in, your C is 1 over V divided P. So when you bring your compressibility in, you have the compressibility, okay, included in the equation. You have CV dP, CV dP. So for that of oil, we have it here. For that of water and that of gas. Okay, all existing together, and contributing to the production of water, of reservoir fluids. Okay, so considering the following as typical for the compressibility of oil, water, and gas as at a pressure of 2000 psi. So this is an example. You have the compressibility of your oil, compressibility of water,